So far, you have learned quite a bit about the law of supply and the law of demand and how the two of them interact in the market system. For this chapter and the next several chapters, we will dig a little bit deeper into the law of supply and the law of demand, what makes them work, as well as how businesses and consumers can use a little bit deeper knowledge to think about the choices that we're making. The reality is we're always making choices. And businesses tend to have a good feel for consumers' decision-making process. Sometimes consumers don't have the best insight into the choices that they're making. So this first chapter that we'll talk about in digging into the law of demand, we're going to focus on a concept called elasticity. So essentially, this is just one of these things that's going to let us look into what really makes the law of demand work. So as an example, just to get you thinking about today's topic, consider this. Last Thursday, there was a businessman traveling on the Los Angeles to New York City flight after learning that afternoon of a required meeting Friday morning. He was sitting next to a retired school teacher who'd been planning on a vacation for months. They paid two very different airfares, but it's the same flight. They're sitting in the same row. They're going to the same destination. How in the world is it possible that these two people could end up paying such wildly different airfares for the same thing? That's what we're going to discuss today. So the concept that economists use is this concept called elasticity. And elasticity is a measure of our responsiveness to price changes. It is not a measure that tells us whether we want a product or don't want a product. It simply says, how does our behavior change when the price changes? So for example, if we're very sensitive to changes in price, then we have what's called an elastic demand. So essentially what that means is if the price changes and our behavior changes an awful lot, then we are going to be very sensitive to those price changes. We're examining the price. We're looking at what's happening to the prices. And when those prices change, our behavior changes, and that's an elastic demand. On the other hand, an inelastic demand simply says that you're not sensitive to those price changes. When the price changes for a product, it doesn't affect your behavior at all. You continue to purchase the same amount or close to the same amount that you always purchased even before the price change. So really whatever happened to the price doesn't affect your behavior. And you have what's called an inelastic demand. So to work through an example of what this looks like, I want you to think about a patient is given a prescription for a drug to control dangerously high blood pressure. The patient's insurance covers drugs, so the patient only pays a minimum copay. I don't know, maybe it's $5, and that's just the standard. Is the patient's demand for medicine more elastic or more inelastic? Is the patient going to be sensitive to the price changes, elastic, or not sensitive to the price changes, inelastic? There's a couple of keys that are given to help you figure out what's likely to happen to this patient's behavior if the price of this medicine were to change. So notice it's a medicine for dangerously high blood pressure. So do you think if the price of the medicine were a little bit more expensive, the person would just all of a sudden say, oh, yep, forget it, don't want it at all? Or do you think the person probably would say, well, I just have to pay the minimum copay. The insurance pays the rest, so it really doesn't matter to me. The latter is true, and in this case, you're going to have an inelastic demand. Consumer might not even look at the price. He just pays the copay and goes on. And also notice that the behavior doesn't change if the prices go down. So for example, if all of a sudden the price of this medicine were cheaper, the patient doesn't say, oh good, now I can afford to take twice as much. The patient buys the same amount that they always bought. Here's another example. A woman goes to the store to purchase salad dressing. Really doesn't care what flavor or what brand. Maybe it's just she's going to a potluck and she needs a jar of salad dressing to go with her salad and doesn't care what kind it is. Is her demand for salad dressing going to be elastic, sensitive to price changes, or inelastic, not sensitive to price changes? Key here is she doesn't care what kind she gets. So really, she's probably going to be very elastic. She's probably going to actually just look at the prices and find the cheapest one. If the price of brand A is higher than the price of brand B, well, she won't get brand A, she'll just get the cheapest one. So her behavior changes when the prices are different. So the key to understanding elasticity is to know that there's going to be some kind of change in price and some kind of change in quantity that's being demanded. So how do we calculate this? There is a formula, and the formula that we're using is sort of a midpoint formula. For those of you who have calculus experience or are in a calculus class, there's a different way to calculate this, but in this class, we're using what's essentially called a midpoint formula. So in this fraction, the numerator is equal to the percent change in quantity, and the denominator is the percent change in price. So you have two different quantities and two different prices. So as the prices change, the quantities will change, and you simply plug them into the formula. Now, as we go through some examples, I encourage you to please stop the video and work through the examples. Please don't just take my word for it that, yep, there's the number. You need to know how to work the formula also. So here's a demand curve for ice cream. And I would ask to calculate the elasticity as the price goes from $4 to $3. So you'll notice at $4, there's a quantity of 10 gallons demanded, and at a price of $3, there's a quantity of 20 gallons demanded. So simply plugging those numbers into the elasticity formula, 20 minus 10 over 20 plus 10, that's the percent change in quantity. 3 minus 4 over 3 plus 4, that's the percent change in price. And we're going to take the absolute value, and I'll explain that in just a minute, but essentially the absolute value is just the positive of whatever our calculation is. And we end up with a positive number, 2.33. Now notice there are no units to this. It's not $2.30. It's not 2.3%. It's just literally a number. And I'll explain what the number means. But I want you to think about what's happening in this demand curve. As the price drops from $4 to $3, do they gain more revenue or do they lose revenue? Well, at the price of $4, they sell 10, that would be $40 of revenue. At a price of $3, they sell 20, that would be $60 of revenue. They've actually gained $20 of revenue. So they lowered the price and revenue actually increased. They lowered the price and revenue went up. Think about what that means. Maybe people were watching what was going on to the price. And that tiny percent change in price yielded a much larger percent change in the quantity. They sold a whole lot more. And so that offset the drop in the price, and they actually gained revenue. So in this case, I want you to also calculate what happens when the price drops from $2 to $1. Notice it's still a dollar difference, 4 to 3 versus 2 to 1. But look at the percent changes. So as the price drops from 2 to 1, the quantity goes from 30 to 40. Again, it's still just a $10 increase in quantity, but it has to do with percent changes. So the numerator is the percent change in quantity, and the denominator is the percent change in price. And we get a different number, 0.43. Now notice what happens here. When I drop the price from $2 to $1, I'm actually going to lose revenue. I'm going to go from $60 of revenue to $40 of revenue. I'm going to lose money. So dropping the price from $2 to $1, and our elasticity was 0.43, means that maybe people were looking at the price, and even though it dropped, not that many more people bought the product. So what that means is behavior didn't really change too much. So this lets us help interpret these numbers. Essentially, you're inelastic if the absolute value of your elasticity is between 0 and 1. So in the previous example, when we dropped the price from $2 to $1 and got 0.43, that was an inelastic portion of the demand curve. Elastic if our absolute value is greater than 1, as it was when we dropped the price from $4 to $3 and got an elasticity of 2.33. We're unit elastic if elasticity is actually equal to 1. And that happens every now and then. It's important for you to also recognize I use the absolute value of elasticity, because for calculating elasticity of demand, you're always going to get a negative number. As the price goes up, the quantity demanded does what? This is the law of demand. As the price goes up, quantity demanded goes down. If the price goes down, quantity demanded goes up. So you see, they always move in opposite directions. So we would always get a negative number, and people just don't like working with negatives. So economists have always just taken the absolute value. So now you'll notice when the elasticity was greater than 1, and we dropped the price from $4 to $3, we gained revenue. So if you have an elastic product, you would lower your price and increase your revenue. If you have an inelastic product, lowering the price doesn't really do much for your revenue, and in fact, you lose revenue usually. It makes no sense to lower the price on an inelastic item. So let's think about elasticity and some actual measures. There have been studies that have been done, and you don't need to memorize these, but these are just some examples across the board of whether these goods are elastic or inelastic and what the actual numbers revealed. So for example, you'll notice that salt, somebody did a study and found an elasticity of demand of 0.1. That's very inelastic. Now think about this. If salt were on sale this week, would you change your behavior really? Would you say, oh good, it's on sale, I can use twice as much as I used to? Probably not. Actually, there are some people that don't use salt at all. So if the price went down to 0, they probably would still not change their behavior. They still would purchase 0. They wouldn't use it. Maybe it's for a medical reason or something. Same with toothpicks. I mean, there are people that don't use toothpicks. So you can raise and lower the price of toothpicks, and these people aren't going to change their behavior at all. They'll still not buy any toothpicks. Versus think about other goods. For example, Chevy automobiles. Now there's an item that people actually, they look at those prices. They say, well, what's the price of the car? Okay, over at Chevy, this is the price of the car. Oh, well, there's another car over at Ford. Maybe it's for a little bit less. Oh, maybe I'll get the Ford instead. People tend to adjust their behavior. Now, there are a few that, they will always insist on a certain brand, and it doesn't matter what the price is and how the prices change. They will continue to buy Chevys no matter what. But across the board, most automobile consumers, they shop around. They look at the prices and they compare. And those price changes make a difference for most car buyers. So let's think about the things that affect our elasticity. Number one is the number of substitutes. If we perceive there to be a lot of substitutes, we're going to be more elastic. So for example, cars. Well, believe it or not, there are substitutes to a Chevy automobile. You could get a Ford car or a Toyota or a Nissan. You could not get a car at all and get a bike. You could buy a Tesla. You could buy lots of other options besides Chevy automobiles. But notice, you think about salt, maybe there's not as many substitutes to salt. I have a picture here of the potato chip aisle. There's all kinds of options for potato chips. Now, each one tries to portray itself as a little bit different than the other. But a lot of people actually look at prices when it comes to purchasing potato chips. And they walk the aisle and they look around at all the options that are available. The more substitutes there are, the more elastic we tend to become. Another option that affects our elasticity is the percent of income spent on the item. So for example, some of you may be consumers of chewing gum. And I usually ask students what brand and how much do you pay for it. And a lot of students don't really even know how much they're paying for the gum that they're chewing. Well, think about this. Part of the reason may be that I venture to say most students aren't spending the majority of their paycheck on chewing gum, maybe a pack a week or something like that. If you are spending the majority of your paycheck on chewing gum, you might need to also purchase toothpaste and a toothbrush, because that might not be the best for your teeth. But I have a feeling that for some students, the thing that they spend the most money on might be things like rent, cars, big ticket items. Those are the things that we tend to watch the prices on, and little tiny price changes make a big difference in our behavior. So I have an image of Wrigley's gum. At one time, Wrigley's had on their pack of gum 5 cents, and they doubled it to 10 cents and actually printed it on the label, 10 cents. Didn't affect sales. They still sold as many as they ever did. They actually then went to 25 cents, printed it on the label. Didn't really affect sales all that much. People who used to buy it at 5 cents still bought it at 25 cents. They didn't even know. And now, actually, I don't think it's printed on there at all what the price is. People tend not to look at those things when they're small portions of their paycheck. So another thing that affects elasticity is the amount of time that has elapsed since the price change. The longer the time that goes by, the more elastic you're going to become. mostly because you'll probably find some substitutes. So the example I always use is gasoline. There's probably somebody out there that today they have to fill up with gas. They have no choice. They're running on empty. And if they got to the gas station and the price said $4.47, they would complain about it, but they're running on empty, so they'll probably fill up their tank. But now think about this. If it's $4.47 3 months from now, I guarantee you a whole lot of people would be finding some alternative forms of transportation. They might decide they don't want to come to school at all. They may be completely online classes. So the longer the time period that goes by, the more we look around and the price makes a difference for us. There's two other measures of elasticity. They're calculated in similar manners, but in both of these cases, the sign actually makes a difference. So we don't take the absolute value, but we look at the sign, and the sign will mean something for us. The formulas are a little bit similar to the other formula for elasticity of demand. In the numerator will still be the percent change in quantity. That's always the numerator. So income elasticity measures our sensitivity to changes in income. So you'll notice the formula. The numerator is the percent change in quantity. It's the denominator that's different. Here, it's the percent change in income. So you have two different income levels and two different quantities. So think about this. Our income changes might affect our consumer behavior. So for example, maybe you get a raise. How does that affect your purchases of things like travel expenses? Do you go on vacation more because you got a raise? Or how much does a raise affect your purchase of things like macaroni and cheese? Does it affect it at all? Maybe you got a raise and it doesn't really matter for you for mac and cheese. You eat a box a week and it really doesn't matter what your paycheck is. So income elasticity measures our sensitivity to changes in income. So for example, my income rose from $12,000 to $15,000 per year, and my quantity of steaks demanded rose from 3 to 5 per month. So what is my income elasticity? So again, the percent change in quantity is the numerator, and the percent change in income is the denominator. So you simply plug those numbers in, and as you calculate that, you will get a number, and the sign makes a difference. So I encourage you to stop the video and make sure that you can calculate this number. In this case, you should get a positive 2.25. Now think about what that means. My income went up and my quantity also went up. That means this is a normal good because they're moving in the same direction. So a positive income elasticity will imply a normal good. A negative income elasticity implies an inferior good. So we talked about those in chapter 3. Also notice this number is much larger than 1. So that means this is a person who's very sensitive to changes in income when it comes to steak. They got a small percent increase in their wages, and they bought a much larger percent increase in the quantity of steaks. So very sensitive to changes in income. They were just waiting for a raise so they could eat more steak. So a cross-price elasticity measures our sensitivity to changes in the price of related goods. So it says, well, if the price of a related good changes, how does my behavior for this other good change? So you'll remember we talked about substitutes and complements as goods that are related to each other. So in this case, the formula looks a little bit more complicated, but it's still two different prices and two different quantities. And it's the percent change in quantity that's in the numerator. So you have two different goods, A and B, and two different quantities and prices, 1 and 2. So for example, the price of a DVD player goes from $50 to $20, and the quantity demanded of DVD rentals goes from 20 to 100. What's the cross price elasticity? So before you answer this, I question you to think about what kind of relationship do these two goods have? Are they substitutes or are they complements? So then notice we have two different prices and two different quantities. We simply plug those into the formula. Encourage you again, pause the video, work this question out. The sign makes a difference. And if you're getting the wrong sign, it probably means that you've switched your numbers around. Or it means you've got, maybe if you're using parentheses, you've got your parentheses in the wrong place. But in this case, you should end up with a negative number, a negative 1.56. So notice these are goods that are complements. So the price of one good went down and the price of its complementary, or the quantity of its complementary good went up. So as DVD player prices go down, people are going to buy more DVD players, I suppose, which means that the quantity of rentals is going to go up. And in this case, again, you have a number that's, well, mathematically is actually smaller than -1. But think about 1.56 is larger than 1. So this means that in this case, this is an individual who, again, is very sensitive to the prices of DVD players. Once the price drops just a little bit of a percentage, they started renting an awful lot of DVDs. So if you think about goods that are substitutes, they're going to have a positive cross price elasticity, simply because as the price of one good rises, the quantity demanded or the demand of the other good is going to also increase. They move in the same direction. So for example, if Kraft Italian dressing is a substitute for Good Season's Italian dressing. As the price of Kraft goes up, the demand for Good Seasons also goes up. So if they're really good substitutes, if you're going to have things that are almost perfect substitutes, you're going to have an elasticity that's greater than 1. It says, yeah, that tiny price change in Kraft made all the difference in the world and everybody went and bought Good Seasons. That sort of implies they're pretty good substitutes for each other. So in summary, what we have is a measure of how sensitive we are to price changes. It's how does our behavior change when the prices change? It doesn't have to do with whether this is a good we have to have or want to have. It's how does our behavior change? So for example, toothpicks, I would say for most people are not a have to have item. But when the prices change, their behavior probably doesn't change very much. So they'd be inelastic. Elastic means a small percent change in price gives a much larger percent change in quantity demanded. Inelastic means a large percent change in price gives a small percent change in quantity demanded. And we talked about the things that are going to influence our elasticity. And then we also examined our income and cross-price elasticity. So I would encourage you, as you're going through this chapter, please work the problems out in the book. Don't just read the textbook as though it were a novel. Get your calculators out, work the problems, make sure that you can come up with the calculations that are presented in the examples. Make sure that you do some examples. And also know that I've provided a couple of supplementary videos to walk you through even more examples. Now, in class, we're going to discuss these concepts a little bit deeper, as well as how businesses use this information to possibly to influence our behaviors. And I will also just ask if anybody has any questions. But hopefully you've been able to at least work through a couple of these examples.